My name is Ron Riffe, and I have an interesting role at IBM. I'm a business strategist for this. This whole idea of cloud has just created lots of buzz in the marketplace, and I've talked to a lot of clients who their whole idea of cloud has come from their CIO or an IT manager has read a magazine that said something about cloud is good. And so they get this email that says, hey, cloud's good, go, I want one. And can you go get me a strategy for that? What are you going to do with cloud? Has that happened to any of you guys? Yeah. And you go, okay, what's that? What do I do with cloud? And so we get the same kind of question. Some clients ask us, what in the world's a cloud? And how does it apply to storage? On the other hand, we get the same thing going on inside IBM. Executives, watch the advertising from our competitors. It says, cloud's good, we're cloud. And they say, I got to have cloud. Go, what's my strategy on cloud? And so they come ask, where's my business strategy on cloud? So what I want to talk to you a little bit about is some practical applications of cloud. What does it really mean, and what's driving this whole industry conversation around cloud? Woj started out with this picture earlier on today, and I think it is the driver for this whole cloud conversation. You've got more data than you can afford to store. And so everybody's always trying to come up with creative ways to make that narrow. The gap narrow between the amount of data that you're going to have to store and the amount of budget you have to spend on storing it. Cloud is just another creative conversation around, hey, I can make that narrow up. And you guys have heard all the buzz, especially from the public storage cloud providers, people who offer storage capacity in the cloud on the internet. You can go to a website, stick in a credit card, and get 50 gigabytes worth of capacity to stick something on. It has created an awful lot of buzz, but it has sort of created the question that I want to help you answer today, which is, okay, so I've heard the buzz, I know that these guys are offering capacity, people like Amazon S3 or Nirvanix, they're offering storage capacity at really low dollars per terabyte. In some cases, it's less than the dollars per terabyte that I'm spending on my own infrastructure. So I'm kind of curious, what is it that those guys do that's different than what I'm doing that allows them to operate at such low cost? And can I use any of those techniques inside my own place to help me be more efficient? I think that's at the center of the whole cloud conversation. Some people, when you start looking at those techniques and insourcing them into your own house, they say, oh, well, that's cloud enabling yourself, or that's creating a private storage cloud, whatever you want to call it. What I'd like to do is step you through what I think the techniques that these public people are using that you might be able to use inside your enterprises to lower the cost and narrow the gap between the amount of data that you have to store and the budget that you have to store it with. And I think there are 4 specific areas that I want to look at. The first one is the idea of virtualization. How many of you guys are using virtual servers of some kind? Everybody's got to raise their hand, right? VMware, Power VM, KVM, ZVM, your virtual servers. The whole idea of virtualization, everybody gets it for the server environment. That's how you get efficiency out of servers. Well, the same thing happens in storage. One of the things that public storage cloud providers do is they virtualize all their storage. It's not physical arrays anymore. They've eliminated the limits, if that makes sense, eliminated the limits of a physical disk array that has 10 wrapped around the outside of it, and you can see it and touch it, and they've created a virtual storage environment. And that creates all kinds of positive benefits from an efficiency standpoint. So we'll talk a little bit about that. The second one is that these guys, they have standardized services, which means that, I'll give you the example, when you go to Amazon S3 or Nirvana, one of these public things, you get a catalog. It says, here's the kind of storage we offer. We offer this kind or that kind, and this kind costs a little bit more than that kind. And they have different service levels to them. And you pick, and you say, that's the kind I want for my application, and you buy it. Well, that standardization helps them to operate much more efficiently because they can identify the exact kind of hardware, infrastructure, software that they need in order to deliver that service. Problem that we have, and we'll talk a lot more about this in most private enterprises, is there's no standardization. You never know what kind of request is coming. Because of that, you end up buying tier 1 everything so that you can service whatever request shows up, and that's expensive. Cloud service providers don't do that. Right? So they standardize the set of services, and we're going to talk a little bit about how you can leverage that same idea in your infrastructure. The third one is, they call it self-service provisioning. Now in a public environment, that's me to a website with my credit card, I just provision my storage. In a private environment, how many of you are ready to let every one of your end users loose on provisioning their own storage whenever they feel like it?
Oh, me.
Yeah. Vendors. You wouldn't be like, oh, that'd be great. In a private environment, more often the request, you want it to stop someplace so you can approve it. And the idea of self-service is more of highly automated provisioning for administrators. Right? You push a button and voila, it happens. So it cuts down people costs. And public providers do this so they don't have to hire an entire army of folks to go manage the increasing demand on their infrastructure. And the final one is the idea of chargeback, or at least showback. Right? So because what public folks have figured out, not only does it help them to keep their business running, but people make a lot better decision when they understand the implications of their decision on cost. If I'm a public provider and I say I've got really great kind of storage and really sorry kind of storage, and there's no charge for either one, what are you going to pick? the really great, and it's going to cost them a lot more to operate. But if you do chargeback, or at least inside a private enterprise showback, show them what the implications of their decisions are, you'll get some of your application users probably making a better decision about what kind of storage requirement that they're asking for. That makes sense? So 4 areas. Now we're going to take a little bit deeper look at each one of those. The first one I want to start with is this idea of virtualization. So IBM has started talking about a storage hypervisor. In fact, the whole industry has really started talking about a storage hypervisor. If you've been paying as close attention as I get paid to do on what analysts are saying, what independent bloggers are saying, what press people are starting to write about, the idea of a storage hypervisor is really getting talked about a lot in the industry. And it, I think it's just a natural next step, because server hypervisors, everybody gets it. Server hypervisors have a hypervisor platform. Think about VMware, vSphere, or Power VM, IBM's Power VM. And they also have hypervisor management. Think about VMware vCenter on top of vSphere, or IBM Director or VM Control on top of Power VM. They come in combinations, and they have done extraordinary things for the server environment. Now, as server hypervisors are getting sort of pervasive in your shops, CIOs are turning their attention towards, what do I do next to get towards this virtual data center? And the idea of a server hypervisor, a storage hypervisor being the next step, it just makes complete sense. Now, in the IBM portfolio, our storage hypervisor is both a storage virtualization platform, the SAN volume controller, and storage virtualization management, the Tivoli Storage Productivity Center. The two kind of go together and create a virtual storage environment. And the job, if you watch down in the bottom right-hand corner of your screen, the job of a storage hypervisor, even a server hypervisor, is to take a physical asset and then create a virtual instantiation, virtual layer up on top of it so that you can free yourself from the bounds of the physical server. And this sort of shows up at the very top a Power VM environment running a whole stack of different operating systems from Linux to AIX to i5OS. Then VMware running Windows and Solaris x86 and Linux and NetWare. And in the storage environment, a whole stack of different hardware vendors, all with one virtual storage layer up on top. Now the cool thing about an environment like this is you can start moving things around. If you have multiple servers, you have mobility. If you have multiple storage arrays from different vendors, I can move virtual disks back and forth. I have a common set of capabilities. I can pack in virtual entities on top of this physical hardware and really jack up utilization. Right? So these are some of the things that virtual servers have done, and in storage environments that virtual storage is also doing. In this case, it's, again, IBM SAN volume controller creates that virtual layer of virtual disk above the disk arrays from virtually anybody's environment. Now, we just announced this morning a new enhancement on this that I think is very significant also. Again, if you'll watch the bottom right-hand corner, that virtualization layer, the same volume controller, this is a picture of a single virtual data center. What we announced this morning is an ability to stretch that virtual data center across long distances, now creating a virtual data center that really has no walls, right? Or at least walls that are over the horizon a little ways, 300 kilometers apart. Now, the significance of that is that these virtual volumes you saw down in the bottom corner, a single virtual volume can now span 300 kilometers and lots of different arrays and a couple of different physical data centers. What's cool about that? Anybody? DR, right? I'm going to combine that stretched cluster configuration down there at the bottom with the virtual server's ability to move workloads from physical server to physical server, VMware vMotion, Power VM Live Partition Mobility, and now what have I done? I've given myself the ability to decide on the fly, hey, I want to move an entire workload from one data center to another data center while the workload's up and online and running, right? Now I might want to do that because I'm planning on doing some power maintenance on the site. I might want to do that because my primary data center is here on Manhattan and I just watched the news report and a dadgum hurricane's coming up the coast and I want to move inland, right? Yes, sir?
The 300 kilometers, is that a physical limit based on latencies, network latencies and such?
All right, so the question is, why 300 kilometers? What limits it there? And it's the speed of light. You want to do this at a synchronous, so you have data at both data centers synchronously replicated at the same time. And so 300 kilometers is what gives us that synchronous ability. Now, beyond that, you can do asynchronous replication, which I'll draw you a picture of here in a minute. But if you're doing asynchronous replication, you no longer have the ability to just push a button and live move an application because this data wouldn't be there. Yeah.
Thank you.
This is significant, right? I mean, 300 kilometers is, I mean, it's not all the way around the world, but at least, in this geography, it's across the river. So, you've got some sort of DR associated with it, right? It's a live partition, a live ability to move workloads, load balancing, disaster avoidance, outage avoidance, get me out of harm's way in a virtual environment. Takes that idea of a virtual data center and really expands it. Okay, so that's the idea of a storage hypervisor. Now, that capability, if you think about the various recovery scenarios that you might want to go through. The first one we talked about is up there at the top, you know, hey, I know the hurricane's coming, I want to get out of the way. Disaster avoidance, if you will. And that's sort of the live migration, high availability, virtual data center without walls configuration. The second one down is, you know, oops, the hurricane already hit, now I got to recover my data center. And that's a different sort of a recovery scenario. You're not live moving anything anymore because there's nothing live to move. And so the IBM storage hypervisor has the ability to not only be in this sort of HA stretched virtual data center configuration, but also simultaneously be in a disaster, long-term asynchronous replication disaster configuration at the same time. And we have clients that will look at the high availability configuration on their own premise because they have a couple of data centers that are within 300 kilometers of each other, and then they'll contract with, you know, IBM BCRS or someone else to be their third center and replicate data into there for their live application systems.
What kind of network are we using here to do this? Network transfer this data over.
For which one?
Let's say for the second one where you have a lot of data because say
Here?
Yeah, say like New York when Irene was coming.
Yep.
And say Viacom, for instance, you say no, we want to move the data over to say where it's safe to the West Coast. Well, no, it wouldn't be, that would be less than that would be more than 300.
Well, yeah. So at the top,
Yeah.
this is 300 kilometers, and you wouldn't be going all the way to the West Coast.
Yeah.
Here, that's still 300 kilometers. This could be anywhere in the world, right? Thousands of kilometers away.
Yeah.
The configuration that you're going to have here is essentially a fiber channel SAN that is, logically connected across two different data centers. The one on the bottom end can be much lower bandwidth length because you're transmitting asynchronous bursts of data very long distances.
I think though, if you consider that, it would be the size of the pipe, right, going across, right? I mean, one company is not going to need as much, or much more than the next company. But if you've got to push across 30 TVs a night, you're going to need a pretty thick pipe, right?
Yeah.
Yep.
But the limit is still 300.
300 kilometers here for real time.
Right.
This is, thousands of kilometers because it's an asynchronous, it can be an asynchronous operation. We call it global mirror in our disk arrays. That's RDF and the EMC's terminology, etc. Now, interestingly, the configuration I just talked about, where I had two live data centers of my own, and I'm using BCRS or something for another. If you remember back to the TSM conversations that we've been having, this could be node replication, a TSM server here and a TSM server here for your backup data. So these things start to layer in on top of each other and fit nicely. Does that make sense? Okay. The one on the bottom is also, you have the scenario of, darn, I just goofed up my data and now I got to recover it. A file. Somebody got a virus. Oops, I finger checked and deleted the file. You also have that kind of recovery scenario as well that the other two don't necessarily provide for. Now the IBM storage hypervisor provides a hypervisor layer snapshot capability. It's a hardware assist that can snapshot data that's sitting on really any disk array that you might have underneath. you're running EMC gear or IBM gear or Hitachi gear or NetApp gear, it doesn't really matter. The hypervisor does the hardware assist snapshot. And as Oren was talking about earlier, the flash copy manager in TSM is directly integrated with the hypervisor layer snapshot, so that you can snapshot any of the Unix applications, Linux applications, Windows applications, the new VMware support that Oren described, being able to snapshot a whole VMware environment at one time and plug it into TSM. That's what's drawn down here on the bottom. The hypervisor layer has the ability to provide for snapshots regardless of what disk arrays you happen to be using. Okay? So, one of the great things about the storage hypervisor is the stretched cluster configuration that we just announced today. It raises the utilization of your environment and provides for all kinds of different resiliency, DR avoidance, disaster recovery, and operational recovery of individual files, all built into the storage hypervisor layer, regardless of what kind of hardware you're using. And that's one of the techniques that these storage service providers are using to be able to operate at much lower cost than what most people are operating at today, because they're not doing these things. Any questions on the storage hypervisor? Okay.
I do have a question. I'm
Yeah.
sorry. With regards to the storage hypervisor, if I were to snapshot, for example, Oracle, where does, in this picture, where is Oracle or the other application that I'm snapping become flash aware? In other words, where does it pause and write to some logs while I'm flashing data, and how is that picked up?
So the question was, if you're using this hardware assist, or even not, but a hardware assist storage hypervisor snapshot like down here at the bottom, how do you coordinate with the application to let him know you're about to do that? Right. So he needs to flush buffers and prepare logs and all of that. That's the job of the flash copy manager. So the flash copy manager has an agent that sits next to the Oracle instance on the Oracle server, and he coordinates that operation. He says, okay, Oracle, I'm about to do this, and he executes the Oracle RMAN functions to flush buffers, get logs prepared, and then he turns around to the storage hypervisor and says, it's time, here's the list of LUNs that the Oracle's sitting on, go snap those. And he coordinates that whole thing. On the recovery side, he also provides a little interface to the Oracle administrator that says, here's the list of snapshots that you have of your Oracle database, so you can recover whichever one you want to.
Yeah, thank you.
Good question. Yeah, the flash copy manager is regardless of what kind of hardware you're using, if you have a storage hypervisor in place, it's a big deal for improving, modernizing the recovery environment. All right, so the next one is this idea of standardized storage services, and this is the one I get a chuckle out of folks when we get ready to talk about it. So, in most data centers, yours included, you have different data types. You go look at across the top of that list, and we have IBM consulting services that'll come in and help you understand the different types of data that you have, and maybe the kinds of services that are really required by that kind of data. It'll end up being things like your database data, your email data. You might have database for this application group and email for that other application group, but in general it looks like this. And most data centers that we talk to, they end up having between 15 and 20 total kinds of data. Now, the idea with a service catalog, if you will, is that you want to identify what are the requirements, the actual requirements, along a number of different areas for that data, so that you can know when you have to go provision new email capacity exactly what you need to go provision. And it's things like capacity, efficiency, how fast do you need the performance, How resilient does the access to the data need to be? Disaster protection. And it can be, you know, all the way from I don't need much at all the way to I got to have the very best. Now the place I always get the chuckle is, you know your customers. If you were to go sit down with them and say, okay, I've got 4 different areas: capacity, performance, resilience, disaster protection. Let's talk about your application. What do you really need? What are they going to say?
Need it all.
Yep.
I need best for everything. And that's where the whole idea of chargeback or showback comes in. We'll get to that in a second. But let's suppose for a second that you're having a coherent conversation with a client, and you sort of work past a picture like that to something else, where everything doesn't have to be tier 1. There's some rational conversation about what does the business really need. And what you do with this, you have this conversation for each one of the data types. And then you take that and you input it into a storage service catalog. Now, IBM happens to have one. It's called Tivoli Storage Productivity Center. And for just a second here, I'm going to sort of take you through the somewhat mundane task of defining the storage service catalog, show you how it works, so prove to you that it exists, and then we'll get into what now can you do with that. Right? So let's take database, for example. Capacity efficiency, I/O performance, data access resilience, and disaster protection. So the first thing I'm going to do in Tivoli Storage Productivity Center is I'm going to say I want to define a new storage service catalog entry. In this case, I'm going to define database. Right? And once I tell them I'm about to go define the catalog entry for database, then I'm going to go into a set of screens that's going to let me define capacity efficiency, what are my metrics there, as well as I/O performance. And you'll see it's things like what RAID level do you want? Are you using virtual volumes or not? Do you want solid state disks in these or not? Sort of generic requirements or definitions around what kind of access do I want this application to have. After that, I'm going to then get asked a question, does this particular service catalog entry, is it going to have definitions for data access resilience and disaster recovery or not? And in this case, I'm going to say, yeah, I would like to have disaster recovery defined as part of this as well. So the next set of screens will ask us about data access resilience. What sort of I/O pathing do you want? Is this always going to be multi-path? Do you want it load balanced or round robin? How do you want in general for this to operate? And then the final set is for disaster recovery. How do you want your DR to operate? Do you want mirrors or snapshots, or if it's going to be mirrors, what kind of mirrors, local or global, etc. Right? With that set of definitions, then, I now have a fully functional SLA, if you will, about when somebody asks for database, what kind of storage should they expect to get? Now, the cool thing about this is that definition is now implanted in Tivoli Storage Productivity Center. And the reason I want it there is because now I'm open for business. I have a definition for database, and I can start receiving requests from those DBAs. They say, I want 50 new gigabytes of database capacity. And I don't have to fool around with or think about what to provide them. All I need to know is, what server do you want that attached to? It's 50 gigabytes, I know how big it is, and it's database. That's all the information I as an administrator need from now on. And now I can go into that highly automated, we call it self-service provisioning. So with those 3 pieces of information, you just told me you want 50 new gigabytes of database space. I'm going to go in, and you see on the left-hand side here, I picked database as the catalog entry that's being requested. You notice I've got shared files and video also there. You'll select database space as the catalog entry that the guy is requesting. He will have told you what server is supposed to be able to access that information. You'll see here on the bottom right-hand corner that I've already done this operation 4 times, so there's 4 groups of capacity been allocated. Since he's told you what server is supposed to be able to access this new group, I'll just go select that server off of my list, and then I'll input the amount of capacity. Now I've been saying 50, the chart says 2, imagine 50 in there, right? I'm going to type in 50. That's all I need to know. Database, who gets to access it, how much. And then I push the run now. So as an administrator, I don't know how often you guys have done provisioning recently, but there's a whole lot of steps that go behind this. And you're probably doing them largely manually today, which creates a lot of workload for people. And remember, as that the data keeps growing and the budget stays flat, either those people are going to completely explode or work 24 hours a day, or they've got to get more efficient. Right? And this is how they get more efficient. You go from manually provisioning, the disk, and manually zoning the LUNs, or zoning the network, and manually setting up the multi-pathing device drivers, and manually associating the replication pairs. You eliminate all that stuff, you push run now, and all that is done for you in a highly automated self-service provisioning way. One of the techniques that these storage service providers are using to dramatically reduce their cost. The storage hypervisor improves utilization, makes everything more flexible and mobile. The storage service catalog combined with self-service provisioning makes the human beings way more productive so that things can get provisioned really, really rapidly. Right? The final piece is this idea of chargeback. Now, if you think about, we've created a storage service catalog entry for database, and some guys just asked for 50 new gigabytes of database. I want to charge him for that, or at least show him what it's costing me to provide that for him, right? So that he has an idea, and he doesn't always ask for the most expensive kind of capacity for everything that he uses. He can either feel the pain of being charged back, or know what his impact is on the business, and maybe help the business to be more efficient. So this idea of chargeback is important. Now what we've done with this storage hypervisor and Tivoli Storage Productivity Center is, we know what the service level is, database, and we know how much people have requested. So we gathered that information up and fed it right into the Tivoli Usage and Accounting Manager, so that if you choose, you can send a bill back to your customer. Right? And this is a picture of one of those invoices. In this case, you see in the middle row there that's got the block pointing to it, I've got database space. This particular client was human resource, the HR department, human resources. And you'll see under database there's disk space allocated and disk space consumed. And you can kind of think of that as the difference between non-thin provisioning and thin provisioning. I heard a really great definition of thin provisioning the other day. Anybody, do you know if you're using thin provisioning widely in your enterprise or not? No. I had a great definition of thin provisioning. Thin provisioning is essentially, guy calls you up and says, I need 50 gigabytes, but he's only going to use 3. So you don't give him 50, you give him 3 and wait till he actually writes data to expand out his capacity. You do on the fly. The analyst I was talking to that had the great analogy said, can you imagine if like airlines didn't thin provision their space in their airplanes? They reserved spaces for all my kids if I might choose to bring them along, but and so they wouldn't sell those spaces to anybody else just on the hopes that I might show up someday with my kids. The room would look like this. There'd be nobody sitting next to each other except for IBM guys in the back. Thin provisioning allows you to jam in as much data as possible into your available resources. Well, So that was a little digression. In the bill, we can tell you whether it allow you the flexibility to charge somebody based on what they asked for or based on what they actually used. Your choice. Right? And in this case, on the top one, we're choosing to charge back based on what they asked for. They asked for 250 gigabytes of storage. We picked a rate that we want to charge that guy for that kind of service level, and it produces a bill. On the bottom one, you'll see in email we chose to charge back based on what they actually used. They asked for 100, they only used 97. We picked a rate, and it produced a bill. So you see that this idea of chargeback can be an extremely powerful tool in helping to make your environment much more efficient. So 4 areas. You can call them cloud if you want to, public cloud, private cloud, but it's techniques that public cloud storage providers are using that you can use inside your shop today with products from IBM to really help drive down cost and improve efficiency. Yes, sir?
Do you have sort of I like this view, do you have sort of a showback view as well that, you go to management and say, look, I know we're not charging, but here are your biggest abusers of the disk?
Sure. So the question was, do I necessarily have to send an invoice or can I just show them? And yeah, the Tivoli Storage Productivity Center, as I mentioned, collects all the information on who's using what, down to at the file system level, the file level, at the volume level, at the group level, like is done here. Now, there have been reports in Tivoli Storage Productivity Center that can do the showback for a long time. All we've done here, I say all, it's significant. We've extracted that information and handed it to an invoicing system, right? So you can send an invoice. Okay. So the 4 areas, the storage hypervisor we talked about is if you want to take that step towards implementing some of these techniques, System Storage SAN Volume Controller is the storage hypervisor platform, and then Tivoli Storage Productivity Center is the management that goes with that. They come in twos. The second area is if you want to do this storage service catalog and highly automated provisioning bit, that comes from Tivoli Storage Productivity Center Standard Edition. And then finally, if you want to move on to actually sending an invoice like the public guys do, that it may be the underappreciated, but might be one of the more powerful things you can do to start to drive down your costs, because everybody won't be asking for tier 1 anymore. Tivoli Usage and Accounting Manager. Visually, there's a little bit of I guess I'll just draw a little picture for you. You can imagine a virtual storage environment, maybe call it your storage cloud, if that's what you want to call it. Now you're going to be cloud people. Everything below the line. I've created a private storage cloud service. It's virtualized with the SAN Volume Controller. I can pick whatever hardware I choose to pick and stick it in there. I've got a common service with the SAN Volume Controller, common management for the entire thing, Tivoli Storage Productivity Center, and usage-based chargeback, Tivoli Usage and Accounting Manager. That's my private cloud storage service. If your boss is saying, cloud must be good, I want one, that's what you can describe. I can do this for you, and here it is. Now, on the top, natively, this you have the ability to access this with applications that are on servers running Fiber Channel or on servers running iSCSI, block access. And in the theme of TSM, imagine that server on the left-hand side is a big TSM server, and you're storing the disk storage pool in your public store or your private storage cloud. Make sense? It's deduplicated from TSM. It's then provisioned in the storage cloud. It's highly efficient. Right? Now, we also have the ability to add other protocols to the top end of this. If you'd like to access this private storage cloud with a tape protocol, a virtual tape library like ProtectTier, for example, we offer a ProtectTier gateway that will sit right in on top, and over on the left-hand side, maybe that left-hand server is your TSM server, and you're writing out to a ProtectTier storage pool. And that ProtectTier storage pool is deduplicated with a ProtectTier gateway, but the actual physical disks are sitting inside of your private storage cloud, if that makes sense. And also, if you have file servers, you want to put file data into this private storage cloud, we offer a scale-out network attached storage gateway that can sit right in on top and just enable NFS, CIFS, kind of protocols up on top, NAS protocols. So you sort of start getting the picture of how you can respond back to CIOs or IT managers who are saying, cloud, I want cloud. This is how you take those techniques that the public storage cloud providers are offering, and you start to implement those inside your data center. Okay. There's a whole lot more reading you could do. In fact, you'd probably be able to pull out some good words and clips if you look online at the Tivoli Storage blog, ibm.com/blogs/Tivoli Storage, and you do a search on cloud-storage. That'll get you to a series of blogs that describe exactly this in great detail, maybe help you in communicating inside your shop. Any questions?
I have a question for Richard.
Yep. No, go ahead.
All right. Richard?
Yes, sir.
Yeah. The client updates on the 6.2. How easy of use is that when you're doing I think mostly that's for Windows, right? You cannot use it on 6.2 uses it.
Yeah, if you're using the IBM client updates, it now with 6.3 supports Windows, Linux, Solaris, HPUX, and AIX. Is that correct?
Yes.
Yes.
We use a different approach, and that is both installs and updates, and it's for all the platforms and almost all the clients. So TDP for SQL, so on and so on.
And how easy of use is that?
Very straightforward, easy. Yeah, centralized configuration control, etc. But that's not part of TSM itself. But I can talk to you about what we do there and how we do it.
Okay.
Okay. But
So I'm going to translate real quick for those who are watching on the webcast. We had a question back on the TSM set of stuff about auto client update from TSM 6.2 and 6.3. How easy is it, and what platforms does it cover? 6.2 was Windows only. 6.3 picked up a whole lot of Unix and Linux platforms, and the answer was it's really easy to use. Good answer. Yeah.
And then okay, the other one that I have, you were talking about replicating the database, the TSM database.
Yes, sir.
But what I didn't hear was as well as also the data, because my question to that would be just the database. So what happened now is if we lost the storage here, what good is the database?
We replicate both the TSM server database using HADR, and we also copy the data to the remote location using classic copy pool, dedupe to dedupe storage pool. So the data also goes over the link to that remote TSM system. But it does not have TSM running today because we didn't have metadata and data replication with TSM 6.1, 6.2. So the model to date has been to replicate the TSM server database using HADR and then classic copy pool, but in dedupe form only, the data itself between the primary and that HADR instance. So both the TSM server data and the database are on that system, so when we stand up, we're ready to go.
6.3.
Sorry.
6.3.
6.3 allows replication of both the data and the metadata.
You gotta do
Yeah, real-time live while TSM's running.
Is that right?
I think we gotta go to 6.3.
6.3 cover.
All right, thank you.
Any other questions? Private cloud storage, other things related to TSM that we talked about during the day? All right. Good. So I'll check out for a moment.